Okay, the next topic on 5.5 is all about functions. So the last topic we need to discuss is function notation. And we've seen some of this, but let's lay everything out so it's clear. Remember that a function is just an input-output relationship, where an input, the domain, input is the domain, that's the x values, gets mapped to exactly one output, the range, or the y values. Okay, so that basically means x cannot 2-time. So for every, if we look at the table, so a function can be defined two ways, or three ways, sorry. One is a table, two algebraically, and three using a graph. So if we look at the table, every x value corresponds to one unique y value. So that makes this a function, right? Nobody's cheating. I mean, even if you have 1, 0, 1, 2, 3, and you had, let's say that the table looked like this. This would be an example of a different kind of function. I'll call it g of x. And why do we name this? F of x, meaning that's just one function. G of x would be a different function. If I had 0, 1, 2, 3, and the answer was always 2, 2, 2, 2, is that a function? Yes, because doesn't matter if y is the same as long as x would be different. Yes, it is a horizontal line. It would be g of x equals 2 or y equals 2, which would be a horizontal line. Exactly. If you were to, this would be the algebraic right here, just like it's saying here, algebraic. And this would be, you know, if you were to graph it on the graph, it would be a graph, right? The graph would be a horizontal line. Now let's look at a different table. Let's say I had the table, I'm going to call it x, y, 3, 2, 3, 4, 4. 1, 2, 3, 4. Is that a function? No. Why is it not a function? Because right here, the 4 is repeating. So since I have two different values of x, when it comes to functions, if I say, hey, what is x equals 4? And then you tell me 3 and 4, which one is it? I can't decide, you know. X is like the question, what is, right? And y would be the answer to that question. So here, so this gets a little complicated, and maybe we could go back to functions another time too, but let's look at this. Then we have an algebraic statement. So this algebraic statement has an infinite set of ordered pairs. If I wanted to make this into a table, I would have x values, and I could have f of x values. I could plug in any value of x. What would I get if I plug in x is 0? 2. What would I get if I plug in x is 1? I'm just using, and this is part of the reason why we love to use 0 and 1. Whenever x is 0, we have a y-intercept, right? X is 1, that's pretty easy. 1 plus 2 plus 2. What's that? 5. So you see, these are only 2 points. How many different points could I get with that equation? I could get an infinite number because I could even put in negatives, I could put in fractions, and every x value that goes in, I'm going to get a new y value that comes out. Okay, and then on the graph here, I can see that none of the x values are repeating. Now, if I were to draw a vertical line test. Have you ever heard of the vertical line test? Vertical line test. The vertical line test is saying, if I were to draw a vertical line, now does anybody know the equation of that vertical line right there that I just drew? X equals 1. What is the name of this vertical line right here? Yes. I can only cross the line one time. That means x is not repeating because x is repeating infinitely along this vertical line. But I only crossed the graph one time, meaning that this point is 3 comma maybe 17. This point right here would be 1 comma, looks like, I don't know, what, 5? So that means that that x value of 1 is only paired up with one value of y. So x is not repeating. In the table, we were seeing x was repeating here, which made it not a function, right? If I were to graph something like this, if I were to graph the points 3, or sorry, 4, 1, 2, 3, 4, 3, right here, right? 4, 4 would be right above it. 4, 4, 4, 3. You see how if I draw a vertical line between those 2 points, oh, x equals 4, I would connect 2 points, so that means x is repeating. So if I can draw a line, a vertical line, and cross 2 points, it means the x value is repeating, meaning it's not a function. Okay, that's just a little bit of repeat on functions. That's one of the concepts that always gets students, especially Math 95. Okay, so let's look at these. How do we evaluate using the table? So let's evaluate each type of function. If I look at the table now, if I were to graph these ordered pair, I would only have 4 points. I would not be connecting them. So I don't know how they came up with these numbers. There's no formula to generate more numbers. This function contains only 4 points. So if I say f of 0 would be 4 because the x value is 0, the y value is 4. F of 4 would be negative 11, good. What about f of 7? There is no f of 7, is there? There's no 7. So we could say this is undefined or does not exist. It's not part of my table, and I don't have a formula, in order to plug 7 in. So there are a finite number of points here. Mm-hmm. So that's a good question. Could we come up with a formula based on a table? If they told me it was a quadratic formula, or if they told me it was a linear formula, then I could possibly come up with a rule for it if it followed a pattern. But because there's no explanation and there's no other given information, then no. And we would not, and because there's just 4 points here, we would not connect those points. If we were to graph it, we would just have 4 distinct points on the graph, no lines between them, because it's not continuous, okay? These are just 4 independent points. Okay, algebraically, evaluate the following for the function defined by the equation. So here, f of 0, oh, that one's easy. We can do that on sight, right? What would you do to find f of 0? Yeah, so you could plug in 0 and come up with what the answer would be. What would be left? 1. And this is a special point. Why is that a special point? Or what is it called? If I were to graph that point, it would be, where would it be located? Because the ordered pair would be 0, 1, right? X is 0, Y is 1. Yes, so this is going to be a y-intercept. Guys, anytime x equals 0, you will have a y-intercept because all along the y-axis, x is equal to 0. In fact, that is the equation of the y-axis, is x equals 0. And that's partly why that's one of our favorite points, because that was easy math. I actually don't like doing really hard, tedious math. I like doing easy mental math. Most mathematicians do. We like shortcuts, right? Okay, here, this one's a little bit harder, but I'm going to have to plug in negative 2 wherever I see x. So I will have to do more math here. Negative 2 to the third power minus negative 2 plus 1. Once I plug that number in, I'm going to follow the order of operations. We were just mentioning the order of operations. Please excuse my dear Aunt Sally. Okay, left to right, left to right. So what am I going to do first? Parentheses Okay, there's nothing to do inside the parentheses. I just used the parenthesis to plug in the number. And that's always a really good idea. Whenever you're evaluating, I would put the number that you're replacing x with in parentheses. Nothing to do inside parentheses. So what am I going to do next? Exponents. Negative 2 to the third power. Now, a lot of people will make the mistake they'll want to multiply these first and then take that to the third power. But notice that 3 is not being taken to the third power. So we have 3 times, anybody know what negative 2 to the third power is? Yes, negative 8, right? Minus negative 2 is the same thing as plus 2 plus 1. What comes next in the order of operations? Yep, so we get negative 24 plus 2 plus 1 equals negative 21. Okay, so this would be the ordered pair negative 2, negative 21. Notice how it's a function because when I plug in one value of x, I only get one value of y. I didn't get two different answers, right? Any questions on how I got that? All right, the next one for a lot of people is really hard, but we can figure this out. It's just using the graph. The graph is the exact same idea here, and they actually have this, it looks like an equation. I can't even hardly read it, but you could end up plugging it in if you could read that equation. F of 0. Where am I going to find f of 0? Yeah, the y-intercept. This f of 0 is a y-intercept. So f of 0 equals, what's that point? Looks like 1. I am going to go with 1 as well. Okay? F of 1 is equal to, how would I find f of 1? Where am I going to look for it? Go to, yes, x equals 1. X equals 1 is right here, and that looks like 0, 1, 0. So since I got a y equals 0, what is this called? This one is the y-intercept because it's on the y-axis. This one is called the x-intercept. The x-intercept always happens when what? When y equals 0. Conversely, the y-intercept always happens when x equals 0. So this is the line x equals 0 is this vertical line. The horizontal line, the y-axis, is the same thing as y equals 0. Okay, now let's look at this one. F of 2. How do I find f of 2? Can you tell me how to get to f of 2? What do you mean there's nowhere it can be on there? What's that? I'm going to look, yes, I'm going to look for where x equals 2. I have this ordered pair. Here's where x equals 2. I go down to the line and we get negative 5. So that's the same thing as the ordered pair. 2, negative 5 is the same thing. Okay, what about how do I get to f equals 3? Or not f equals 3, sorry, f of 3. F of 3 where x equals 3. I go over here to 3. This is where x equals 3. Remember this whole vertical line right here is x equals 3. Where does it intersect with my graph? Negative 8. Excellent. Okay. Any questions on that for the graph? So essentially these are always the f of that number in parentheses is the x value. Okay, let's go ahead on to the next page. So here, another use of function notation is the ability to combine functions. The notation is pretty self-explanatory, but let's write out in details. So this is saying f plus g of x. It basically means I'm going to take the function f of x and I'm going to add it to g of x. This means exactly the same thing. Here, I'm going to take the function f of x. I'm going to subtract g of x. And what do you think I'm going to do with these two? F of x times g of x. Okay, so if we look at this here, we have the numerical values. This is coming from our table. If I have f plus g of negative 5, that means f, I'm going to find f of negative 5. I'm going to add it to g of negative 5. Okay, so f of negative 5 is 8. G of negative 5, I go over to my table that is G negative 5 is equal to negative 1, right? Negative 1. Now if I add those two numbers together, what do I get? 7, yes. Okay. Now here, first, what am I going to do? Order matters when it comes to subtraction, right? What's the first thing I need to find? G of 0, right? And then I'm going to subtract f of 0. So it's really much easier if you write it like this. Then we're going to find G of 0. What is G of 0? 10. Good, because remember this is the x value. What's f of 0? Negative 5. Yes, so we have to look for f of x, okay? Then we have 10 minus negative 5 is 15. Good. Okay, here we have f of 3 minus g of 3. What's f of 3, everybody? Good. Negative 10 right here, f of 3. G of 3 is 5. Good. Minus 5. What do we get here? Good. Here we have f of negative 2 times g of negative 2. What's f of negative 2? 3. Good. Here's f of negative 2 is 3. G of negative 2. And multiply those together and you get 0. Good. Evaluate the following. Now I have two different functions. So interesting here, p plus h of x. So this is the same thing as p of x plus h of x. Because I don't have a number, I just have the variable x, that means I'm going to take the entire equation, which is 2x squared minus 3x plus 5. What am I going to add to that, do you think? Yeah, h of x. I'm going to add all of x cubed minus 3x plus 6. Is there anything I can do to simplify that at all? Yes, I can. I can combine the like terms and I can write it in descending order. What would be the descending order combining like terms? It would be start with x cubed would be the first one, followed by, yes, 2x squared, because I'm adding these together, right? So I'm just going to keep adding. Plus or minus, what do I want to do next? Minus 6x, good, because we have these are like terms. And then lastly, plus 11, good. Now here, what is this saying? This is saying to take p of x and do what? Multiply it by h of x. And I'm probably going to have to do this actually on the last page because notice what happens. If I multiply this 2x squared minus 3x plus 5 times x cubed minus 3x plus 6. Do you see that I have to more than FOIL it? I have to FOIL, right? If I were gonna simplify this more, I would need to go multiply, 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 multiply. Okay, so I'm gonna, because in the interest of time, I'm not going to do that, but you can go ahead and do that. It's probably the answer I bet is in the PowerPoint. Okay, now here, p plus h of 2 basically means I could plug in 2 here and I could plug in 2 here and then I could add the two things together. But because I already added the functions together, I will get the same thing if I plug it into my new function, which is p plus h of x. So if I plug it in here as opposed to doing it all here, and then adding those two numbers together, I'll get the exact same thing. So p plus, well, let's just do p of x, no, p of 2 plus h of 2. And that's what we were doing up here as well. If I plug it all into this function, 2 cubed plus 2 times 2 squared minus 6 times 2 plus 11. Do you see how that would be saving myself some work rather than plugging it into the two functions and then adding them together, I should get the exact same thing. So if you want to check that, can everyone figure out what this one is? 2 times 2 squared is also 8, same 8, plus 11, okay? And what do we get? 15. Okay, now I didn't create the function h minus p. So here I'm just going to go h of 0 minus p of 0. But actually those y-intercepts are really easy to find, huh? What is h of 0? If I plug in 0 for x, what am I going to get here? 6. It's the y-intercept, right? What is p of 0? 5. 6 minus 5 is 1. I'm glad they didn't ask us to do the multiply. All right, so that's it for functions, talking more about functions. Any questions that you want to go over about functions? No, probably not because it's 20 minutes in, right?